All right, welcome to the wonderful world of piecewise defined functions. A piecewise defined function is a function defined by at least two equations, or you could call them pieces, each of which applies to a different part of the domain. Here are some examples. On this first example, we have x plus 4 if x is less than 1. We have 2 if x is between 1 and 4, and x minus 5 if x is more than 4. This is an example of an equation of a piecewise function. The other ones are just different types of piecewise functions. None of them are related to each other. These are just examples of 4 different piecewise functions and how you may see them. Look at this graph of a piecewise function. We're going to find the output for the following inputs using the graph. First, we have f of negative 1. In order to find the output for f of negative 1, the first thing we have to do is find out where negative 1 is as an input. So that's where we are. We're going to go either up or down to touch the graph. In this case, we're going to go up to touch the graph. And then we're going to look at the corresponding y value. This gives us an output of 1. So let's see how f of 0 looks. In order to get f of 0, we're going to go to 0 on the x-axis. As you can see, the output of 0 is 0. In order to find f of 1, we're going to go to 1 on the x-axis. And then we're going to go up to the graph. Now what you'll notice here is that we did not go up to the open circle. Instead, we went to the closed circle. Technically, that open circle does not exist. Instead, we get an answer of 1. Now when we try to get f of 2, we're going to go to 2 on the x-axis. And as we go up, we're going to pass by that open circle because technically it does not exist. And we're going to go to where that closed circle is. The closed circle means it does exist. And that makes our answer 3. Last one for this graph. We're going to find f of 3 by going to 3 on the x-axis. And as we go up to the graph, we see the answer is 3. Now let's evaluate the piecewise function when we're given a set of equations. The first thing we need to do is select the function based on which domain the input fits in. If I'm trying to find f of negative 3 is less than 0. So I'm going to pick the equation that has if x is less than 0. So we're going to end up using 6x minus 1 and plugging negative 3 in as my input. So let's put the input in the selected function. 6 times negative 3 is negative 18 minus 1 is negative 19. 0 fits in the domain of x is greater than or equal to 0. So we're just going to put that input in the selected function. 7 times 0 is 0 plus 3 is 3. Four is greater than 0, so we're going to put that in the second function. 7 times 4 is 28 plus 3 is 31. So as you can see, we just need to put it in the function that it tells you to. You're basically just following instructions. They will always tell you what the x's are or what the limits are for using each equation in a piecewise function. They won't give you a list of equations without telling you where you can plug inputs in. Here we have a word problem. When a diabetic takes long-acting insulin, the insulin reaches its peak effect on the blood sugar level in about 3 hours. This effect remains fairly constant for 5 hours, then declines and is very low until the next injection. In a typical patient, the level of insulin might be modeled by the following function. So f of t will be 40t plus 100 if t is between 0 and 3. It will be 220 if t is between 3 and 8. It will be negative 80t plus 860 if t is between 8 and 10. And it will just be 60 if t is between 10 and 24. Here, f of t represents the blood sugar level at time t hours after the time of injection. If a patient takes insulin at 6 a.m., find the blood sugar at each of the following times. And we're going to find it at 7 a.m., 11 a.m., 3 p.m., and 5 p.m. Now, while the top part explains where these equations came about, we actually don't need it for this problem. So we're going to take that out. So let's first focus on the 7 a.m. It does not mean that t is 7. Remember, the patient takes the insulin at 6 a.m. So 7 a.m. is just 1 hour away. So that means that t is equal to 1. So now we have to find out which domain can t be 1. Now, as you can see, 1 is between 0 and 3. So we're going to use that first equation. And we're going to take that input of 1 and place it inside the equation. So 40 times 1 is 40, plus 100 is 140. That's the answer to part A. At 11 a.m., how much time has passed? 5 hours. Where does 5 hours fit into our domain? 5 is between 3 and 8, so we're going to use the second equation, which just simply says 220. When there's no variable in there, that's a constant answer. No matter what t is between 3 and 8, the answer is just going to be 220. Next we have 3 p.m., which is a little bit more difficult. You'll have to use your fingers and your toes. But from 6 a.m. to 12 is 6 hours. And then another 3 hours will be 9 hours. So where does that fit in? Well, 9 is in between 8 and 10, so we're going to use the third equation, and we're just going to put 9 as our input. And here goes our answer. Now we're going to do 5 p.m. So from 6 to 12 is 6 hours, and then another 5 hours gives us 11 hours. Where does this fit? Fits right on that last equation, which is a constant 60. So that means our answer is 60. If you have any questions, feel free to reach out. Hopefully you understood everything in this video, and I'll catch you in the next video.